give a quick introduction. So Christoph comes to us from the MIT School of Architecture and Planning and the Building Technology program. He's a building scientist and architectural educator, leading the Sustainable Design Lab at MIT, developing design workflows, planning tools, and metrics to evaluate the environmental performance of buildings and neighborhoods. And he's also the head of Solema, a technology company, and Harvard spinoff, as well as strategic development advisor for MapDwell, a solar mapping company and MIT spinoff. So please welcome Christoph Reinhart.
Thanks a lot, Justin. Can you hear me well? Okay, yep. Great, excellent. Well, thanks a lot to Justin and to Mariana for inviting me. Great pleasure to be talking again to the IBPSA-Boston chapter. I'm always self-conscious because I only talked to you 12 months ago, so I hope I'm not going to bore you. I do my best. This is a slide that I shared with us last year when we were all brand new in Zoom world, and now we have gotten painfully acquainted to being remote, but it seems like the end is in sight. So I just want to do a big shout out if you're in the Boston area to get the vac if you can. And for those who are joining us from elsewhere, I hope you'll soon be in a similar situation. Convince all your friends, your family, everybody to get it so that we can be back together in person. The presentation was really great, Krista. I think especially after just teaching a semester class on tweaking, trying to model in energy plus natural ventilation concepts, I know how painful it sometimes is just to find out what the simulations assumptions of some tools are. So I think it takes a lot of bravery and confidence in building science to come up with these projects. And it's probably, 30% building science, 30% simulations, and 40% talking to people and convincing clients that this is actually working. And maybe what I want to talk about today is also about, discussions of people having together. I'm called this presentation, this short presentation, Simulations in Practice. And I want to reflect on some of the things that we have learned by working with a group of practitioners and manufacturers on developing building performance software. Before I get started, I want, as always, do a big shout out to my academic family, which is the Building Technology program at MIT, where both the two kind people that invited me are alumni from, as well as to our friends and software co-software developers at Solema, who are making the climate studio software that I'm going to use as an example today. So before I get started getting into that, some other thoughts that we have been working on during the last 12 months at MIT. And the coming 3-4 slides, hopefully you haven't seen them. I think they're helpful if you work in the general area of resource efficiency in the built environment, trying to develop a more direct link between current debates on climate change and what we can do and have to do in our field. So very briefly, how do we want to frame that? If we want to keep global temperature rise under 1.5 degrees Celsius, then the IPCC tells us we have 580 gigatons of CO2 left to burn. And if you look at the recent news, there's of course a lot going on. Some large car manufacturers are promising us that by 2035 they want to be carbon neutral. The Biden administration said that the electricity sector should be somehow carbon neutral by 2035. So let's assume we can claim more than a 40% in our slow building sector. Let's say we take half of this carbon. That means we have in total 300 gigatons of CO2 and 30 years left to make the global building stock carbon neutral. That's like one idea. And then, of course, the global building stock is going to double until 2050. So we also have to basically reduce carbon emissions in the built world and create a net zero new world of buildings. So this is a pretty simple model that we built here, just looking at the next 30 years. If we keep our current global renovation rate at 1% per year, and we only take our time to make all new construction carbon neutral by 2050, we're going to burn through all the carbon that we've left as a global society by 2050. So some key ideas that, or goals that we've been working with, is that we really have to increase our renovation rate globally to 5% per year for all existing buildings, and we need solutions for carbon neutral solutions for new construction by 2030. Which sounds a bit as a pipe dream, but this is effectively what we need. Again, two numbers: 5% retrofitting rate, carbon neutrality for new construction in 10 years. So we've been working on both aspects, but I'm mostly going to focus on the second one, how to do carbon neutral construction in new buildings. But before I do that, I think especially when they're in the US, this is an exciting time. There seems to be a fresh, new natural wind that goes through the Department of Energy. I think if you follow what Secretary Granholm has announced, there's obviously a deep desire to make all existing 130 million US homes more energy efficient. And our small contributions that we hope to do here is we developed this new web app called Ubermio. If you just type this into your URL browser, you'll find it. And what it does, it greatly simplifies the process if you have shapefiles and you have some zoning descriptions for your city to build an urban building energy model of a small and a large city. And we've been trying to work with this with a number of organizations and cities throughout the US and internationally recently. And another thing that I just wanted, for those of you interested, we've been working with some colleagues at MIT, Jake Jacobi, John Riley, and at NBT, Zach Berzola, on a white paper of how the stimulus bill fund could be spent on buildings as well to increase the global retrofitting rate. And our proposal here is we want to have a 10-year program that increases for single-family homes, the retrofitting rate to 4%, looking at how much this would cost if we would implement energy efficiency and electrification. We predict about $250 billion that would have to come from the federal government to reduce the payback time to 5 years for all renovations. This would lead to about 250,000 new jobs directly in the clean tech sector spread across the US. And that would hopefully help us to kind of bend the curve towards a net zero global US building stock, at least initially for single family homes. And then of course, we want to expand this onto different building types. So now I want to shift gears and talk more about how do we get more or all design teams to explore carbon neutral design concepts in new construction. And here I'm going to go a little back. I'm sorry if you've seen these slides before. This takes us back 10 years when Holly Samuelson and Dee Lance and I did a survey of about 100 firms, mostly located in the US and Canada. And we knew that they were using simulation tools, so we wanted to understand, so how effective is the use? So very simple question: do the simulation change your design? And what we found at that time, long time ago, is then when you have in-house modelers, the chances of having a big impact is actually larger than when you hire lead consultants after the fact, which is, if you think of the process, not very surprising. We repeated this analysis with a survey 3 years ago with prominent US AEC firms. And what we actually found, this firm has a pretty extensive sustainability group, that the feeling was that in only a third of the time, the simulations really have an impact on design. And this is not for lack of trying, this is just because it's hard. And we wanted to, well, first understand, is there at least an interest that we are changing the profession and the way simulations are being used in the process. And so in that survey, we also asked the experts and the designers within the same firm, what about daylighting? Do the designers want to do that themselves? And we got a clear majority vote for yes. So there was confidence that they could be doing it themselves. We also asked the same for energy use, and I think that got a lot of the experts, probably because I would be one of them, very nervous, because what does it mean to do an energy analysis? And I'm gonna talk about what I think what designers could also do to elevate the discussions with their consultants in a little bit. So we took this as a mandate, and I talked about that last year when we had started. For the past 2.5 years, we've been working with this product advisory group, and I want to talk about this process a little more. And if you look at the firms, these are basically environmental consulting firms, prominent architecture firms, large and small, and facade product envelope daylighting product manufacturer. So the process here really is that we have these monthly discussions with this wonderful group where we talk about what we have developed, but it's also about what should we do next when it comes to changing and improving tools. And I think the important point there really is that not every analysis should be done. These discussions really help us to focus. And I think that is it's my personal belief that when you develop tools in our arena, we, of course, on the research side, we should try everything and look at all kinds of different analysis modes. But then there is one point when we see, well, how mature is that? Should we add this as yet another gimmick or feature, or should we be more deliberate so that a larger group of people can understand how to make their building as efficient as possible? So for me, this has been a very useful experience by just seeing, is anybody using a certain type of analysis? Is that a good analysis or not? And I think we need to have a lot more discussions like this, and a forum like these local chapters where we have a more mixed audience of practitioners and simulationists. That's very useful. So the outcome of this is Climate Studio, which is similar to Diva Rhino plugin. If you haven't tried it and you're an educator, I think we have it at over 200 schools are using it for teaching right now. And since we have this more powerful tool available, what I tried, especially last September, together with Alpha Asano, was the TA for that class. This is an introductory class at MIT where we teach architects in half a term how to do a daylighting and energy analysis. And we tried these 8 steps towards net zero. And what you read here is not very surprising. Site selection, climate analysis. We start with daylight because that's a better form giver than energy, and then photovoltaics. But I just want to go a bit through the process and how this looks like using an example student project here, which was done by Chris Allen and Alan Reinhardt. The last name is, there's no relationship, direct relationship here. So when you look at the site analysis, of course, you can start with, and architecture schools are very strong at that, looking at, walk score, overall urban context. And then I think everybody can and should do very quickly an Energy Star portfolio manager target finding exercise to just get a sense what is good, what is bad. And then we all want to do climate analysis. And that I think I would always say a key idea is that you have to focus. Don't try to do everything. But in this case, for example, they designed an office building in Texas. So the focus was really on solar gains management. And that's kind of the theme that this building that they designed picked up. And I would say over the last couple of years, what has been really a game changer when you start doing a daylighting analysis, that it's now so fast that you can actually do a daylighting analysis of a whole building. Not too long ago, basically, when you model the building, you had to wait hours to just get anywhere. And that wasn't very conducive to design. Now with progressive ray tracing still based on radiance, we can basically look at a whole building and do real massing exercises. So it's not the simulation that keeps us that limits us. It's how fast we can model something and our own imagination, which I think is great. So in this case, we are at a point where they looked at basically a closed block out of 3 buildings that formed an arc and then the actual arc. And then they found that this building could be pretty close to 100% daylit. And then the next step was to say, okay, let's look at the facade design where they played with different louver settings. Here, they only went through a few iterations. You could obviously spend months going through that, where you basically try to keep the daylighting level still high, but getting rid of direct excess solar radiation when you don't want it. So this is pretty successful here. I'm still at 99% daylit, but I got rid of all this extra ASE, annual solar exposure. And now I think something that is particularly exciting is our ability in general to look at glare in way higher resolution than we ever could. So within Climate Studio, for example, when you look at here, this section of the building, when we are zooming in, then each of these pizza slices represents an annual calculation that tells you how much is somebody looking this way where the pizza slice is pointing, or I guess the other way around, when you're how often do I experience discomfort? And then what you find is there's a lot of red, but it doesn't matter. All this tells you is when you have your nose pressed against the curtain wall facade and you're looking out, you're experiencing glare, which is not necessarily a problem because your laptop is not going to be, or your screen in that position. So here you actually see how fast the fall off is. So you can use this directly to basically combine your, furniture layout with the glare potential or danger of glare within a space. And then moving on, adding on electric lighting. This is something that by being able to link very quickly to existing manufacturer data, you can quickly get a sense of what's the current lighting power density. And that's, of course, the big, nice success experience for any designer when you compare the current really low lighting power densities that LEDs can achieve, then you look like a hero compared to the relatively high lighting power densities that are still in the standards. And then I think this is a key switch. And this is what I talk about. This is, I think, the type of energy use intensity analysis that a lot of designers can try their hands on early on doing the schematic design. So you're using a code compliant building and then you run just through the works until you reach your target level. And then when you're under your target level in a case like this, then you combine that with a photovoltaic analysis, and then in principle, you end up with a net zero building. So I would love to, and we can talk endlessly this debate, so how is it really that easy? And now, of course, all the questions of this are extremely simplified HVAC models, occupant behavior is more difficult. By just saying we have a very low U value, that doesn't mean you get that low U value. You have to really work out on the facade. But I think the big benefit of this analysis very early on, that it explains to a design team, to individuals, what's required to get to net zero. And probably this rough order of magnitude targets that you establish here for your envelope and for your HVAC system is probably representative of what you will really have to do in the actual building. And of course, we should say it again and again and again, getting to net zero is really, really hard, right? So these goals that we set to ourselves, even though we need to get there, and there is, I would say, a societal expectation, that is not easy to realize. So if you don't know what to do over the summer, or if you know some people that want to learn about this in your firm, we actually have this free Mooc class at MIT that the MIT Energy Initiative sponsored. We are starting, as it happens today. You can enroll, it's all free. We had about 30,000 people last year taking the class, and hopefully we have others joining us this year again. Actually, the second largest group of countries after the US that participated in this was South America and India. And obviously not everybody has access to Rhino and Grasshopper there. So Alpha Asano developed this really great tool called Klima Plus, which based on your smartphone, you can basically run the same type of analysis that I just laid out for a box, not for a full building. But I think it's a good starting point. And obviously we want this tool to empower people all over the world to do this type of analysis. Let's see, how am I doing time-wise? Okay, I'll wrap up in a couple of minutes. Another aspect that I just wanted to talk about that also came out of our product advisory group is this question of reliable data. And I think us and many others have, in a way, for a long time said, well, we have some generic default numbers for certain simulation settings, but we leave it to the practitioners. Just go talk to the manufacturer, which I don't think always happens, especially in the speed of the design process. So we've been trying to work very explicitly with manufacturers for clear glazings. For example, we are just linking the International Glazing Database. But for less common systems, we work, for example, with a translucent glazing manufacturer to, based on measured data, BSDF data that they had for their product, put this right into the software and you see directly the physical properties. So similarly for smart glass, which obviously had a lot of success stories recently, we've been working with 3 global manufacturers, View, Saint-Gobain, and Kinestral, on having all their products in there that creates, obviously, the ability for a lot of people to just test out these systems and see if they work effectively. And now brand new, actually, something that we just put in is a tubular skylight. These type of systems, if you have seen them, allow you not only to daylit the space directly under a roof, that we can go 2 stories down. So basically, in order to model something like this, John Sargent at Solemma developed a slightly different version of radiance, which basically takes a ray to a diffuser, and we call this the split surface BSDS. Then we jump the ray somewhere else so that we can model this type of system. And so you can place it directly within your environment. Details are under the Climate Studio docs. And that allows you then, when you have a space like this, to get the daylight distributions for the whole year for systems like this in place as well. So wrapping it up, in summary, I think as a field overall, we need to convince now building owners and design teams that they at least pursue carbon neutrality as an initial goal, because just time is running out. I think one of the methods we can contribute to that is just training the current and the coming generation of architects and climate consultants in these methods and tools. And I think in parallel to convince these owners as well to especially retrofit their buildings, we have to build political momentum and federal needs to secure federal support from the government to get these payback times to under 5 years. And the idea here of under 5 years is that if you think of the first McKinsey report that told us that building retrofits pay is 20 years old, and still people need shorter payback times in order to implement these retrofitting measures in their buildings. And with that, I'm at my 20 minutes plus.
Okay, thank you so much, Christoph. It's always a treat to see what you've been working on, even in the 1 year, I think, since you last presented to the chapter. A lot of new developments. Questions for Christoph? You can either raise your hand and speak them or type them in the chat here. Looks like we already have a couple comments. Is it possible to simulate manual shading control using Climate Studio?
You can model dynamic systems. Right now we have the ASE, the lead daylighting control in there, but we'll be adding other manual controls as well. So the lead control, if you're familiar with the system, basically says when you have for more than 5% of the floor area, more than 1,000 lux direct sunlight, then the shading gets closed and otherwise it gets opened. But you can also add your own schedules in there as well if you want to control these systems differently. I could talk for hours what I think about this approach, but this is where we are right now. The engine is Energy Plus.
For targeting net zero, how about the contribution from the embodied energy? Another question.
Oh, that's great. Yeah, no, I mean, due to time constraints, I haven't talked about this. This is, of course, a very busy field, and it's great a lot of people have been working on the data. We recently just have worked, Ramon Weber from our lab has worked together with Caitlin Miller on some methods to auto evaluate what the embodied material due to structure in new buildings is, and we'll be adding that as well. So right now, the process that we've always used, we looked at the energy model and the materials that is in the elements of the energy model, but our energy model obviously doesn't have all these structural components. So I think, and this is obviously a key component of the embodied energy. So we are adding that right now. And if somebody's interested, feel free to send me an email. I'm sure we can share a preprint of that paper, which will be presented at the IASSS conference.
You
do have a hand raised. To the person with their hand raised, would you like to?
Good to see you.
Good to see you too. Thanks so much for your presentation, Professor Reinhardt. You're always great. I just wanted to just like have sort of like question. Maybe this is more of a like in the future that you mentioned the 8 step to net zero, which is great. Have you also thought about like developing like including some other like contents like thermal comfort or like radiation on the facade, some like HVA system, like peak load and things like this? Just curious.
Oh yeah. I mean, obviously, you cannot and should not design any building that isn't thermally comfortable. I just, in what I talked about now, try to keep it to a really clean structure that you can teach to individuals within just one term. Adding to that thermal comfort, ideally as automated as possible, is of course a good idea. There's a funny sound. I don't know what that is.
But this is really great. Thanks so much for your presentation. I really enjoyed it.
I owe you an email. I'm sorry.
Yeah. Okay. I'll send you if I have any further questions.
So do you have time for one or two more, Christoph?
I am good. No, thank you all. I mean, an hour is so I can stick around for some time if there are questions.
Okay. Let's see.
Becomes a little faster. Maybe you just tell me, Justin.
Yeah.
What
I see another one in the chat here. How to translate simulation results to design modifications.
Yeah, that's super hard. And I think that is really, this is why I'm a big fan of, well, first reducing the number of workflows that we use and really focus so that there's a recurring pattern of results that we can look at and that you just become more fluent is what is that you don't have to start from scratch trying to understand each result. And then hopefully, depending on who does the simulations, it's great it happens within one firm. But even there, if you think of a larger architecture firm, you come up with these innovative simulations, and then you probably have 180 seconds to get your design principle convinced that this is a good idea. So I think this is where repetition is good. Of course, that doesn't work when you push the envelope. So the graph that Krista shared with us, that was like a piece of art in itself. That is something that when you have I would even say, would like to hear what Krista says. I think that graph you cannot show initially to a design principle. You basically have to do that work, and then you have to dumb it down and just say, trust me. Right?
Yeah, I think that what Christoph said is true. Like, it's really good to start your simulations with like principle-based simulations. So like you do all your orientations and you do a couple of window to wall ratios saying, this is generally the landscape of what you're going to get. And then you tell them when you're going to do simulations. Don't let designers ask you every time they do a design change that you're going to do a simulation, because it just doesn't end up resulting in like a good workflow or a good design. I think you have to kind of lead the process. It's the way to success.
Yeah, I agree. And I think that's very interesting. I mean, my hope is obviously, as you know, not to replace any consultants or think that any designers can do the same thing. But I think by at least getting some, fundamentals, ideas of what the general size of different heat flows is that you need to get to net zero, that helps you to say, well, let's try to get there.
And from the chat, can we use BSDF materials for daylighting simulations in Climate Studio?
Yeah, you can import them directly if you have them.
And how are you collecting data across the world for future prediction of energy consumption? It's primary data or secondary data?
So climate change? Is that the question? Justin, is that climate change?
I'm just reading in, Dr. Balaji, NC, feel free to chime in if you're still on the call. But
I mean, generally, climate change is, of course, a big topic that modeling that in buildings. Right now, there are a few programs out there, including Weathershift. Thanks, big shout out to Arbour for allowing us to use this in practice, especially not in practice, in teaching here. I think we need a lot more of these type of tools. There's actually an interesting activity right now at Caltech called the Caltech Climate Alliance, which is developing a new global circulation models. And we've been in discussions with them in how far one could link these global circulations models directly to future climate change predictions, just so that we have an infrastructure for everywhere in the world to get there. That's hugely challenging, especially if you're in certain parts of the world where you're at this transition climates, where right now natural ventilation might just work, and then if you wait 20 years, it's getting too hot. I think we really have to pinpoint those areas.
And are there plans for studies on integrating smart algorithms to models like machine learning?
Yeah, no, I think that's always a good idea. I think for that, you ideally create open APIs and let people go nuts. I mean, another good way, and I'm a big fan of this, going nuts and trying machine learning algorithms. But I would say they are the best link in is to use just the Grasshopper components, because then you can, develop your own libraries and just link them up.
Excellent. Did someone have their hand raised? If so, feel free to.
I think sorry, I can't.
Chala, you answered my question. I asked from the chat. After that, I raised my hand. You answered. Thank you so much.
Okay.
Sure. It's even more fun if you ask directly. That makes it more. Plus that way, Justin and I don't have to speculate.
Tired of hearing my voice. Another one. Can Climate Studio be run in the cloud infrastructure, AWS, for example, just to get faster radiance times?
No, it's super fast. No need to.
Okay. Looks like some folks have posted links to tutorials.
Great.
For the simulation, so.
Can I ask you a question, Christoph?
Yeah, of course.
Hi.
Hello.
Well, it's more common. I mean, I've worked for many years with your tools, and my students are very eager to pick up Climate Studio also. But the challenge I think we all face, and this is then turning into a question, is that the 8 steps you bring forward, and I've used similar sort of steps which really sort of nail down the reduction of energy use, are challenging for designers who've done this for many years differently, or decades, right? There's a tendency to push the simulation to the end, not understanding that then you can't get back to the first mistake you've already made. So how do we convince old-time designers to change the way they design?
Oh, that is hard. Well, let's say, how do we do it with the new designers? To teach old dogs new tricks. I mean, in terms of teaching pedagogy, we have every first year undergraduate or graduate MArch student at MIT has to take this class first. And within our building technology sequence, we basically say we are starting with in technology with light, energy, and form. And we don't care about structures yet. I always say I don't mind if the building floats 3 feet above the ground in the first term, as long as everything else goes. And then, of course, in the second term, reality and the G factor sets in, and then we have an integrated studio. So I think that approach as a general idea works well. Yeah, how to convince people that are used to another workflow, I think that's hard. Maybe have them, if you get them in continuing education classes, that's great. I mean, I would say I haven't encountered much resistance, but probably the people that want to work with us directly, the designers, are open to this concept in the first place.
Yeah, but I think that's something we really have to think about harder, because it's also our colleagues, and I'm not trying to step on anybody's feet here, but it's, if we don't turn around the way everybody designs, not just the new folks, I think there will be some resistance still when they enter offices. And I know you're working with folks who do it maybe anyway, but there are many out there who don't. So that's just, I think, what I've encountered.
Yeah, I mean, the good thing is you get a lot of pressure, including from the AIA with their new design guidelines, where, they basically tell you, right, this is not just a cute idea anymore. Anybody should do simulations, clients. And I mean, without simulation, without this approach, if a client asks you to get to net zero, there's absolutely no way you're going to get there, right?
Mm-hmm. I agree. I'm totally in with you. So